Hi, BC students. So I'm going over Riemann sums today. So this question says, consider the function. I switched out e to the x with square root of x, but it should be the exact same process. So yeah, on the interval of 0 to 8, approximate the area under the curve using a left Riemann sums with 4 rectangles and our intervals from 0 to 8. Okay, that's totally fine. We don't have a picture of the function, but that's totally fine. We can still do this calculation without a picture. So for approximating the area under the curve with Riemann sums, all we're really doing again is just combining, I'd say, the areas of rectangles. That's all we're really doing, right? Because we're approximating the area, combining the areas of rectangles. Okay, so let's find the area of a rectangle, we need the base and the height, right? So the base in this case is the width. So width of the rectangles. In this case, we know our interval is from 0 to 8. So our interval has a length of 8. So it's going to be, let's say this is on the interval of a to b, right? So our interval is going to be from length b minus a divided by the number of rectangles. So that's going to be equal to, in this case, 8 minus 0 over the number of rectangles, which is 4, right? So we're going to have 2. So 2 units. So the width of our rectangle is going to be 2 units. And we're going to have 4 rectangles. So let's find the heights of our rectangles. So unlike the width, our heights of our rectangles are each going to be different. And we have 4 rectangles, right? So let's say for our first rectangle, the height is going to be the leftmost interval, right? So we're going from 0 to 8, and then there's 4 rectangles. So it's going to go 0, 2, 4, 6, 8, right? So our first rectangle is going to be here, right? It's going to go from 0 to 2, right? So our left endpoint, right, because we've done left Riemann sums, is going to be 0. So we're going to plug in 0 into f of x. So f of 0 is equal to square root of 0 is equal to 0. So our first rectangle has a height of 0. Basically, we don't have a first rectangle. Our second rectangle is going to be over here, right? It's going to go from 2 to 4. I don't know what the height of the rectangle is yet, but from 2 to 4, I'm putting in 2, right? So f of 2 is equal to square root of 2 is equal to, yeah, it's equal to square root of 2. Our third rectangle is going to be, we're doing a left Riemann sums again, so we're going to the left endpoint for the third rectangle. So it's going to be f of 4 is equal to square root of 4 is equal to 2. Our fourth rectangle, this is our final rectangle, right? Because we're told we have 4 rectangles, is going to use this interval from 6 to 8. So we're going to use the left endpoint, which is 6. So f of 6 is equal to square root of 6. And that's our answer. So sorry, these are our heights. So now we need to multiply the width or the base times the height for each one. So we're going to say, I'm going to say width times height. I'll say width of the first rectangle times height of the first rectangle plus width of the second rectangle. Let's say the area is equal to width of the first rectangle times the height of the first rectangle plus width of the second rectangle times height of the second rectangle. So width of the third times height of the third plus width of the fourth times height of the fourth. Now this is equal to the width of the first rectangle is 2, right? It's always 2 times height. Our height is 0, right? Plus the second rectangle, the width is 2 again. the height is root 2, plus width of the third is 2 again, height is 2, width of the fourth is 2 again, height is root 6. So our answer is going to be 2 root 2 plus 4 plus 2 root 6. And you can literally just leave it as that. So that is the approximate area under the curve using RRAM. Approximate area with LRAM, my bad, LRAM. Okay, so next we're going to use MRAM. Now MRAM is a bit more challenging, I'd say, a bit more confusing. But we're going to just copy and paste the same exact thing here, right? All right. Because the width of the rectangles is going to be the same. So we're combining the areas of rectangles again, right? But our width of our rectangles are still 2 units, right? So let's figure out the height of the rectangles. So I'm just gonna copy and paste this too. The height of our rectangles. So let's just, to make this more clear, soon you'll be able to do this in your head, I think, but from 0 to 8, right? 4, 2, 6, right? So each of these is our rectangles, right? It goes 4 rectangles from 0 to 8. And each has a width of 2, which we can see from 0 to 2, 2 to 4. But now we're using the midpoint to figure out the height. So our first rectangle, right, we're going to find the midpoint. So this first rectangle, right, from 0 to 2, our midpoint is going to be between 0 and 2. So it's going to be 1. Right? So our midpoint is going to be 1. So we're going to put 1 into f of 1 is equal to square root of 1, right? Because I'm, again, using square root of x as my function. For our second rectangle, the midpoint is going to be at 3. So f of 3 is equal to square root of 3. The third rectangle, right, is going to be between 4 and 6. So that's going to be 5. So f of 5 is equal to square root of 5. The next one is between 6 and 8. So that's going to be 7. F of 7 is equal to square root of 7. Right? Because all of these are just x values that we're inputting to get the corresponding y value on the curve. Right? So now we can do width 1 times height 1 plus width 1 times width 2 times height 2 plus width 3 times height 3 plus width 4 times height 4. Can I do that up here? Okay, yeah. So width 1 is 2 times height 1 is square root of 1. So that's just going to be 1. But I'll write it out, square root of 1 plus width 2 is, again, 2 times height 2, which is square root of 3, plus width 3, which is 2 times height 3, which is square root of 5, plus width 4, which is 2 times height 4, which is square root of 7. So that's 2 plus 2 root 3 plus 2 root 5 plus 2 root 7. And this is our approximation using MRAM. Hopefully that makes sense. Yeah.